Hello student, last lecture we continue from this topic laws of logarithm. In a detail, we have to must briefly study about this topic. What are they? Log a to the base a is 1. Log 1 to the any base a is always 0. Log m into n to the base a is always log m to the base a plus log n to the base a. Log to the base a m raised to p. These p go to left hand side of log, that is p log of m to the base a. Log m upon n to the base a is equal to log m to the base a minus log n to the base a. Next, log of 1 upon n we should write is equal to minus 1 log n to the base a. Log m to the base a is equal to n. Then we convert this logarithmic form in an exponential form. A raised to n is equal to m. Suppose a raised to log m to the base a is equal to m always. That means if number is same and log have the number same to the base, then these term will get cancelled and we derive the final answer is equal to m. Log 0 to the base a cannot exist. It is the world mathematical problem. Log of negative number to the base a cannot exist. That means any number have the negative sign. Log is not possible there. Log m to the base a is always equal to log n to the base a. That means if the base are same, then numbers are equal. That means m is equal to n. This most probably called as a change of base rule. Means what? Log b to the base a is equal to log b to the base c upon log a to the base c. I explained these laws of logarithm which useful for the example, so I revise these again. Log a to the base a is equal to 1. Any number to the base same number is equal to always 1. Log of 1 in a universe is always to the base any a is always 0. That is product rule of logarithm or laws of logarithm of the product. Log m into n, if multiplication symbol is there, we should define log m to the base a plus log n to the base a. If log m raised to p is there and base is same a, then these p convert to the left hand side of logarithm, that is log m to the base a, that is the called laws of power function. That is log m raised to p to the base a is equal to p log m to the base a. That is laws of logarithm of power. Next one, log m upon n, that is the quotient law of logarithm. Base is a, then log m to the base a minus log n to the base a. That means the log is goes to both the numbers have the same base but negative sign is there. That is why it is the quotient rule. Log to the base a, but 1 upon n is any number, then we should write n goes to minus 1 by using the law of indices. So minus 1 is there, so using power function it will be goes to left hand side of logarithm, that is minus 1 log n to the base a. We last lectures we study about the topic convert the logarithmic function in an exponential form. This also useful to solve the example. Log m to the base a is equal to n, then a raised to n is equal to m. So base goes to the base, answer goes to index and number goes to equal part. A raised to log m to the base a, that a raised to log a to the base m is equal to m is what? If any number have the log have same base, then log will be get cancelled and number will remain as the same. Log of 0 to the base a is cannot exist. It is universal problem. Log of negative number also to the any base is not possible. If both number have the log function but equal part is there, then m is equal to n. Then log of m to the base a is equal to log of n to the base a. This will be called the change of base rule. Log b to the base a is equal to log b to the base c upon log a to the base c. Laws of logarithm must understand to take the simple example, so we get idea about the exact how to apply there. Suppose first law we know log of 1. Log of 1 to the any base is always 0. Suppose I take log of 1 to the base 3 is always 0. Log of b means what? Log b to the base b is 1. That is log 3 to the base 3 is always 1. Log 4 to the base 4 is always 1. Products. If log x into y to the base b is equal to log x to the base b plus log y to the base b, that means I put the x equal to 2 and y is equal to 3 and base is 5. Then I can distribute log 2 to the base 5 plus log 3 to the base 5. Quotient law. Log x upon y to the base b, we derive log x to the base b minus log y to the base b. That means I put x and y value 3 and 7 and base is 2. Then log 3 upon 7 to the base 2. I should write log 3 to the base 2 minus log 7 to the base 2. Reciprocal. Log to the base b of 1 upon x is minus log x to the base b. Always be careful about the negative sign. In a reciprocal form, that is quotient form is there, then you should write any base. I suppose put b is equal to 2, x is equal to 7. That is log 1 upon 7 to the base 2 is equal to minus log 7 to the base 2. Power any n. Log x raised to n to the base b. We should write n this side. Log x to the base b. This side means the left hand side of logarithm. That is the power law of the logarithm. If I put x equal to 8, n is equal to 2 and base b is equal to 10, then I derive the 2 get to the left hand side of logarithm. 8 remain as the same and 10 remain as the same. So always remind all these laws of logarithm, including this example. Let us start from the simplification, how to simplify some logarithmic function in a single form or derive any answer from the examples. We take the first example, log 32 to the base 2. 32 I can get the 16 into 2 also. I take the numbers one digit, that is 4 into 8. For simplification I derive that. But it is why useful, we discuss this next step. So I can take 4 into 8. It is obviously 32 to the base 2 is equal to, I use the log m plus log n to the log of m into n. Base remains same. That's why log 4 to the base 2 plus log 8 to the base 2. We know that 4 is the square of 2. So it goes to 2 goes to this side and log 2 to the base 2 is always 1. So I derive answer is 2. 8 is 2 raised to 3. So 3 goes to this side and 2 remain here. Log 2 to the base 2 is 1. So we derive the final answer is 2 plus 3 equal to 5. Next one, log 8 to the base 4 plus log 32 to the base 4. Here log m plus log n to the base a is equal to log mn to the base a. That means 8 and 32 goes to multiplication and 4 is there. So 4, 256. Can you guess 256 is the which root? So it is how much force, how much power. So you have derived the log 4 raised to 4 to the base 4. So log 4 to the base 4 get cancelled, that is 1, and we derive the final answer is 4. Log 162 to the base 3 minus log 2 to the base 3 is equal to log, we use log m to the base a minus log n to the base a is log m upon n is log 3 162 upon 2. So I divide 162 by 2, so we derive 81. Again 3's 4th power is 81, so 4 goes to this side, log 3 to the base 3 1, so we derive answer is 4. Next one, log 4 raised to 10 to the base 2 is equal to 10 log of 4 to the base 2. 4 is again the square of 2. 2 get this side, so log 2 to the 2 into 10 and log 2 to the base 2 is 1. So we derive the final answer is 20. Always remind that the laws of logarithm most probably used in an example to derive the exact value from convert the log into single term. We have to use the powers of logarithm, logarithm product law and reciprocal law to derive the above expression. Suppose we take this example in a simple pattern, that is log 1 is always 0, log a to the base is equal to 1, log e to the base is 1. So we take simple example, find log 3 to the base 3. We know that log a to the base a is 1. So I put the value of 3 instead of a, we derive answer is 1. Think about log 5 to the base 5, log 1 upon 3 to the base 1 upon 3. Solve this example as a homework. You may derive the value is 1.